This is the last of the statistics videos. It's on topics 6, 7, and 8. It's on starts on page 20 in your packet. Okay, so first thing we're going to talk about is scatter plots and line of best fit, topic 6. A scatter plot, okay, is a list of or a group of data that someone has plotted on a coordinate grid. Okay, now the data is from someone gathering information about things such as shoe size versus height, age versus heart rate, things like that. Okay, the line of best fit, okay, is the line that goes right through the middle of the data that indicates which direction it's going. Okay, so when we're talking about line of best fit, you have a positive line of best fit. Okay, and if you'll notice the dots, you try to make them as equal as possible on each side, and they're really close to that line, so it has a really good correlation. Negative, okay, goes down to the right just like our slope, has a really good correlation. And then you have none, which means you can't make a line of best fit. There's no correlation. The dots are all over the place. Okay, such an example of that would be people who like ice cream, people who like peanut butter. If you gathered that information together, or people over 50 that like ice cream, I mean, it doesn't work. It doesn't fit. Okay. All right. First example. All right, is age versus heart rate. And if you'll notice, there is a correlation between age versus heart rate. Okay, it's a negative correlation, but there is still a correlation. So I'm going to draw a line through the middle. Okay, this is one way we can figure out what the line of best fit is. Okay, so it can't be C. C is y equals 60, and that would just be a horizontal line through 60. All right, and I really think that this doesn't go all the way up to 80, so it can't be A. Now, this one is really hard to figure out the slope. Really hard. They're both negative. That's right. Okay, one is going down 2 to the right 5, but my graph is not really doing that. But I can still use it since they're going up and down and to the right by the same amount. So I could start here at 75 and go down 2 to the right 1, 2, 3, 4, 5. So down 2 to the right 5. I could also try down 3 to the right 5. And down 2 to the right 5 fits better. Okay? Now another way that you can solve this problem is that you can put all those points into Desmos. So if you have Desmos open, you click on the plus sign and it opens up the table for you. And it'll say table. And you put your x's, so go through and find all of your x points. So there's 15, 15, and then you have to get the in-betweens too. That's about 18 and 19, and those are hard to get. You don't have to be exact on those. You just need to be really, really close. And then you put all your y's in, making sure it's the same point that they match. Okay, then you open up another box, box 2. This is box 1. You type Y1. You don't have to mess with sub 1. Just type Y1. You have your squiggle line, which in the first video, I explained where to find the squiggle line. Okay, click the ABC button and you'll find it. And then type MX1 plus B. The reason we're using 1 here is because the table is in the first box. Okay, that's why we're using 1. Now, once you do that, all of this information pops up automatically, okay? It gives you the slope. It gives you the y-intercept. So as you see, the y-intercept is really close to 75, which is what we said. The slope is negative 0.41, okay? And if you take negative 2 over 5 and divide negative 2 divided by 5, you get negative 0.4. So it's really, really, really close. Okay? As close as we're possibly going to get. So this is just another way to solve that type of problem. You can put it into the table if you're struggling with that. All right? These two problems are a little easier to figure out. Okay? This one, I'm going to draw my line of best fit as close through the middle of the data as I can. It's going down and to the right. Well, I notice I have two slopes that are positive. So I'm going to get rid of them, okay? And only keep these that are negative. They're going through the same y-intercept, so I can't do anything about that. So now I'm just going to count slope. Is it down 3 to the right 5? Or is it down 5 to the right 3? So I'm going to start at negative 2, and I'm going to go down 3 to the right 1, 2, 3, 4, 5. Okay, and see if that one works. I'm also going to go down 5 and to the right 3. So I'm going to guess that C is the one that fits the line the best. Okay? All right, next. This one is going up and to the right, so we can get rid of C and D. Those are both going down. All right, again, they both have the same y-intercept, so that's not going to help us. So now we need to use slope. So 2 over 1 or 1 over 2. So is it going up 2 to the right 1, or is it going right, or is it going up 1 to the right 2? And I'm going to guess that it's going up 2 to the right 1. Up 2 to the right 1. This is up 1 to the right 2. Puts it over here somewhere. Okay? All right, number 3. Draw my line of best fit. If you notice, there's no y-intercept here because they're saying the y-intercept is going through 0. Okay, so they don't have it listed. I do, however, notice that it is going up and to the right, so that means the slope is not negative, the slope is positive. Okay, so I have 4 over 1 for my slope and 1 over 4. So if I use 4 over 1, that's up 1, 2, 3, 4 to the right 1. There is no way that that can be the slope. This can't be it. It's got to be up 1 to the right 4. Okay, so you just got to eliminate some of your answer choices to answer some of these questions. Okay, so eliminating is the best way to answer these. All right, next. This line is going down, so I'm going to get rid of A, and I'm going to get rid of C because those both have a positive slope. B and D both have a negative 1 in front of X, but their y-intercepts are different. B starts at positive 2, D starts at negative 2. Well, this starts at positive 2, so I'm going to say the answer is B. Okay, number 5. Draw you a line of best fit. Okay, so I'm going to give you just a second, okay, to see if you can figure it out. If you want to, you can pause it. Okay, remember you need to look at what direction the line is going. Okay, and then see if the y-intercepts are the same or different, and then look at the slope. Okay. Okay, so as you can see, the slope is positive, so I'm going to get rid of C and D. Okay, y-intercepts are the same, so I can't use those. So I'm going to start at my y-intercept of negative 1. I'm going to go up 3 to the right 4, or I can go up 4 to the right 3. Well, up 3 to the right 4 hits that line a little bit better. Okay. All right, next, number 6. All right, the problem with number 6 is that all of these are in standard form. So one thing you're going to need to do is get them into slope-intercept form. 2x plus 3y equals negative 12. I'm going to subtract my 2x so that I can move it to the other side. 3y equals negative 2x plus 12. Divide by 3. If you'll notice, even before I finish, that says negative 2/3. Well, this is a positive slope, so it can't be that one. Okay? And it also can't be c. And the reason it can't be c is when I move the x over, it becomes negative, right? Well, when I divide by 2, that still leaves me with a negative slope. So it can't be c either. Okay? All right, let's try b. So 2x minus 3y equals 12 minus 2x minus 2x. Now this still gives me a negative 2x here. However, I'm going to divide by a negative 3. And everybody knows what a negative divided by a negative is. It is a positive. So this is a positive 2/3. And 12 divided by a negative 3 is negative 4. Well, this starts at negative 4. Okay, the question is, does it go up to the right 3? Well, it does. So there's your answer. Okay, topic 7, linear regression and correlation coefficients. Linear regression, you're basically finding the function that helps you determine future outcomes. Now, right here, they are giving you the calculator steps, okay? And we have gone over the steps for linear regression in Desmos. So you have both of those, okay? The correlation coefficient, okay, all that tells you is the data related, okay? Are they related to each other? So you have strong positive, strong negative, you have positive and negative. Just because it's negative does not mean it doesn't have a correlation. It only has no correlation if it's 0 or close to 0. And if you notice, as it goes down in number, okay, it becomes weaker, okay? So negative 0.8 and 0.8 are both very strong, okay? They are closely related, which gives me a better indication of what's going to happen in the future. If I got 0.6 as my correlation coefficient when I put data into my calculator or Desmos or wherever, I wouldn't probably use that data, okay? Because it doesn't have a very good correlation. That's the point. Is the data useful? That's what the correlation coefficient kind of tells us. Okay, so let's do this first problem, okay? And we're going to do several problems. I'm going to show you how to do this one in Desmos, okay? So they have given us latitude and temperature, okay? Remember, X is on the top, Y is on the bottom. The line of best fit is Y equals MX plus B. That's the format. Okay? Estimate the temperature. This we're going to plug in. Okay? What's the correlation coefficient? That is R. And then slope and y-intercept. Remember, slope is y divided by x. Okay? Y-intercept is the y-axis. Okay, these are the things we're going to talk about, and we're going to do several problems with these. Okay, so I have a copy of what I did on Desmos for this problem. I pressed the plus sign, up popped a table, and I put in all of my values. So go ahead and do that. Plus sign, pop up a table, put in your values so that you can practice. Okay, so that's the easy part. And the next part's not difficult. You just got to remember how to put it in. Okay? Remember, open up another box. You're going to do Y1, not sub 1. Just put a 1 there. Find your squiggle line. Okay? It's on the ABC. When you pull up the keyboard, click ABC. That's where it is. All right. Then we have to do MX1. Remember the 1 because we're pulling from that table which is in box 1. Plus B. Okay? And so they give us all of our correlation coefficient, slope, y-intercept. It's all there. Okay, go ahead and round. You can round to the hundredths or the tenths. Sometimes it'll tell you what to round to. Okay. All right, so this is what I got from putting it into Desmos. I got a slope of negative 1.06, y-intercept of 92.31. So it's y equals negative 1.06x plus 92.31. That's my line of best fit. That's my function. Okay. Estimate the average temperature for this city at a latitude of 25. So 25 falls right in between 20 and 30, right? Since 25 is latitude and x is latitude, I'm going to plug in 25 for x right here. So negative 1.06 times 25 plus 92.31 is 65.8 degrees Fahrenheit. So at latitude 25, the estimated temperature is 65.8 degrees. Okay? C, what is the correlation coefficient? Well, negative 0.97 is our correlation coefficient. It is a strong negative. It has a good correlation. Okay, just because it's negative does not mean it's weak. Remember that. Last, slope. I always do this when I talk about explaining slope. Slope is y divided by x. Well, for this problem, it is temperature over latitude. And my slope is negative 1.06 over 1. So this helps us explain it if we write it out like this. For every increase in degree of latitude, so for every 1 up on latitude, the temperature decreases by 1.06 degrees Fahrenheit. And I know it decreases because it is negative. Okay? My 1 is positive, my 1.06 is negative. Y-intercept is just the temperature at 0 latitude. Okay? Now, this number, 0, is not the same as this number. Remember, this is just a point. Okay? Just a point. All right? That's all it is. This right here is an estimate of what the y-intercept would be for that function. Okay? Remember, these lines, these dots are not in a straight line. It's different. Okay? If you were talking about somebody makes $10 per hour, that creates a straight line. Because every hour, it's the same. Okay? They're not going to get paid $10 for their first hour, $12 for their second hour, and $8 for their third hour. No. Okay? Linear regression is a little bit different when we're talking about slope and y-intercept than just a regular function. Okay? Okay, so the next one, so I really want to talk about dates. Okay? So this says the information in the table shows Olympic 500-meter men's gold medal speed skating times since 1980. Okay, you are not going to put the years in your calculator or in Desmos. So it says since 1980, so 1980 is actually 0. Okay, so that makes 1984 4, 1988 8, 1992 12, 1994 14, and 1998 18. Okay, you cannot put 1980 in. It won't work. It won't give you the information correctly. Okay, that's just how it is. All right, so when I put this into Desmos, okay, remember this is x, this is y, okay, it gives me a slope of negative 2.29, y-intercept of 430.56, okay. It says estimate the 500-meter time for the 2012 Olympics. 2012. I'm not going to plug in 2012 for x. I'm going to take 2012 and subtract 1980, which gives me 32. Okay, so I'm going to use 32 for x. Okay, so I'm going to plug in 32. All right, negative 2.92 times 32 plus 430.56 equals 337.12. And we're talking about seconds. So in 2012, it only takes them 337.12 seconds. Times have gotten better. And I say better because the less time it takes, the better as far as speed. Okay? Probably better skates, better training. Anything could cause that. Okay? Correlation coefficient, negative 0.81. It's still strong. Not great, but still strong. Strong negative because these values are going in a negative direction. Slope, again, y divided by x. Time divided by year. Negative 2.29 divided by 1. So what my slope means is that for every year increase, okay, the times decrease by 2.29 seconds. Okay? So in year 2013, it should go down by 2.29 seconds again. Okay? So the y-intercept is the time at year 0. And remember what I talked about on the last problem. That y, you just need to know what is the y-intercept. It is your time at year 0. Year 0 is subjective as far as this is concerned. Okay? Number 3, again, year 0, 5, 10, 14, 15, 16, 17, 18. Make sure that you are paying attention. Okay? Pay attention. Because these are not going up by 1s. They're not going up by 5s. They're not going up by 10s. These first few go up by 5 and then 4. Pay attention to the numbers. Okay? And change the years. Alright? So here's our line of best fit after we put it into Desmos. If you need more help with Desmos, just rewind this video. Okay? So 10.58 is my slope, or M. 75.57 is B, or the y-intercept. Okay? I want to estimate the store sales for year 2008. So I'm going to take 2008 and subtract 1980, which was the first year. And that's 28 years later after 1980. Okay? Remember, plugging it in for X, since years is X. And I get $371.81 billion. So 28 years later, they should have $371.81 billion. That's their sales. Okay? What is the correlation coefficient? 0.99 is very good. Very strong positive. So there's a correlation for this problem, a very good correlation between years and sales. So this store is doing well. Well, it's going up every year. Slope, y divided by x. Y is sales, x is years. 10.58 is my slope over 1. So, slope means each year the retail store is open, its sales increase by $10.58 billion. So, in year 2009, it would be 371.81 billion plus 10.58 billion. That's what they're talking about. Okay? Your y-intercept again is the billions of dollars at year 0. Remember, your y-intercept is a number when x is 0. Okay? This one right here is a little different. Okay? You are going to probably need to make a table. It would help you out a lot. Okay? So I'm going to put all my x values. So my first x value is 0, 1, 2, 3, 4, and 5. That's where my points are. Okay? So now I'm going to look at the y value for these points. So at 0 it's 16.5. At 1 it's 17. At 2 it's 17.5. At 3 it's 19. At 4 it's 20. And at 5 it's 20.5. Now, once you have that written down, then you can put it in Desmos. Okay? So go ahead, if you have points, okay, on a graph, and you need to find the line of best fit, you can make a table and put the table in Desmos. Okay? It'll make it a whole lot easier. So when you put it in Desmos, you get a slope of 0.87 and 16.2 is your y-intercept. All right, they want to know the amount spent on books in 2005. Well, our first year was 1990, according to what they said above. So that's 15 years. So I'm going to plug in 15 just like I did on the previous problems. 5. This is the same thing as all the rest of them. This is X. This is Y. Put it into Desmos. Okay? So go ahead and try putting it into Desmos and see if you get the same answers that I get. They want to find a 7-member family. Okay? So you have your 7 there. Okay? Coefficient is very strong. All right, I want to talk about slope again. Slope, y divided by x. Number of gallons of milk over family size. So, every time you increase the family size by 1, your milk drinking increases by 0.89 gallons. That's all it means. Okay, let's talk about the y-intercept. Number of gallons when family size is 0. Well, I know that when family size is 0, that means that you've used 0 gallons. And I know this says negative 0.09. Remember, the linear regression is an estimate, okay? It's not exact because you've just plotted points, and it's giving you an estimate of where that's going to go. All right, number 6. All right, 0, 1, 2, 3. Remember, not using those dates, okay? So, plugging it into, I hope you understand, find the line of best fit, because you're basically just plugging into Desmos, all right? All right, here, again, have a year. I can't put 2002 right here. I need to find out how many years has passed. So, 2002 minus 1994 is 8 years, and that's what I put in there. Very strong positive, so it's a great correlation. Okay, again with slope, Y is schools with computer networks, X is number of years. So my slope, 997.4 over 1. So every year, schools that have computer networks increases by 997.4 schools. That's what my slope means. Last one. Okay, table shows predicted annual cost to raise a child from birth until adulthood. So if you were born in 1988, the annual cost would be $10,700. If you were born in 1991, the annual cost to raise you is $11,700. Okay, so again, this is year 0. 88 to 91 is 3. Make sure you pay attention and put the correct number for X. Okay, so when I put this in Desmos, this is what I got for slope and y-intercept. Okay, so next they want to know how much would it cost someone who's born in 2011. Well, 2011 is 23 years after 1988. So it's going to cost $22,010 a year to raise a child from birth to adulthood. That's what that means. Okay? What is the correlation coefficient? Very strong. Things increase, guys. Clothes, school, everything goes up. You have phones now. It all matters. Okay? All right, slope. Annual cost of child divided by years, 510. What this means is that the annual cost to raise a child from birth to adulthood increases by $510 each year. So, in year 2011, it was $22,010 to raise a child. Well, in year 2012, it's going to be $22,520 per year to raise a child. Okay? All right, so your last page is causation, okay? Causation, all it is Cause and effect. Okay? So, what causes something else? Cause and effect. Okay, so your example of causation. Ice cream vendor at Jones Beach records the number of cones sold with daily temperatures. So do you think that temperature causes ice cream cones to be sold at the beach? Probably. Okay, that's a good causation. Relationship between missed classes and final grades. Does missing classes make your grades lower? Yes, it does. Does smoking cause lung cancer? Yes, it does. Example of no causation. If a student studies, she will get an A. Does studying necessarily mean you're going to get an A? No, maybe a better grade, but not necessarily an A. When Lisa exercises, she's in a better mood. Exercising is not necessarily going to cause a better mood. Last thing, shoe size determines height. Is shoe size going to determine height? No. Now, is there a correlation? Yes, there's a correlation between shoe size and height. There's a correlation between exercise and a better mood, but it doesn't mean that one necessarily causes the other. That's the point of causation. Okay? So remember to look at the end of the packet for any problems from above that were extra practice, because I'll have the answers back there. And this will be the last video for statistics.